For the following atoms, 1. Draw the shell model. 2. Draw the orbital diagram. And 3. Write the electron configuration. First one is boron. So the first thing you do is you locate your element in the periodic table. Boron is right there. It's in period 1, 2. Yes, it's in period 2. So therefore it's going to have 2 shells. Alright, part 1 is the shell model. So boron has a nucleus, and boron has 5 protons. Its atomic number is 5, so therefore it's got 5 protons, yes? So 5 protons, and it's got neutrons, the number of which depends on the isotope, yes? And again, we determined earlier that boron is period 2, so it's going to have 2 shells. 1, 2. The first shell is going to have how many electrons? 1, 2. Count the number of squares. Yes? 1, 2. 1, 2. And then the second shell is going to have how many? So starting from the left up to the element, you have 1, 2, 3. So 3 electrons on the second shell. So that will be the orbital diagram, or not orbital diagram, the shell model for boron. Part 2, draw the orbital diagram. So for the first shell you have 1s. Again, for each shell you start with S, and then if you need it, the next one is P, and then if you need it, then D. Okay, so 1s, 1 representing the first shell, yes? So on that, in that orbital you have 1, 2 electrons. So 1 is going up and 1 is going down. So this is it for the first shell, only 1 orbital. For the second shell you have 2s, okay, and then 2p. 1, 2, 3. 2p, and whenever you have P, you're going to have 3 subshells. 1, 2, 3. Okay, so let's start filling those orbitals out. So each orbital can contain a maximum of 2 electrons. So those 2 are those 2 electrons. The next 2 are up, down. So that would be that electron and that electron. Yes? And then in the 2p subshell, you have just 1 electron, so that goes there. Yes? And part 3, write the electron configuration. So the electron configuration, you can just base it on your orbital diagram. It's 1s2, 2s2, and then 2p1. Yes? 1s2, 2s2, 2p1. Superscript 2 because in 1s you have 2 electrons, in 2s you have 2 electrons, and in 2p you only have 1 electron. Alright, let's do part B, sulfur. So sulfur is right there. Where is sulfur? It's right there. So it's in period 3. 1, 2, 3. Period 3, meaning it has 3 shells. And the number of protons is 16 because its atomic number is 16, yes? So you start with a nucleus. It's got 16 protons, and then neutrons. Again, the number of neutrons depends on the isotope. 3 shells representing 3 periods, yes? 2, 3. On the first shell you have 2 electrons. 1, 2. On the second shell you have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And on the third shell you have how many electrons? 1, 2, 3, 4, 5, 6. Sulfur is right there, so you stop there. So on the third shell you only have 6, yes? 1, 2, 3, 4, 5, 6. Alright, so this is part I. Part II. The orbital diagram. So for the first shell, you only have one S. Yes? For the second shell, you have 2S and 2P. 1, 2, 3. Whenever you have a P, it's going to have 3 dashes. Yes? And then for the third shell, you have a 3S and a 3P. There is a 3D, but let's not worry about it. This is Chem 105. Okay, so in 1s, you have those 2 electrons. One is up, one is down. So X and X. 2s, you have 2 electrons. That will come from your second shell, yes? So 1, 2, up, down. And then 2p, you have 2, 4, 6. 1, 2, 3, 4, 5, 6. So you're going to use up those electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then next is 3s. 3s can contain 2 electrons. So 1, 2, 1, 2. And finally 3p. You have, how many do you have left? 1, 2, 3, 4. So you put those 4 electrons into those orbitals. So before pairing up, make sure that each one gets 1. 1, 2, 3, and then 4, representing that, and that electron. And that is our orbital diagram for sulfur. And finally, part III, the electron configuration is just 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 3p4. 1s2, 2s2, 2p6, 3s2, 3p4.